This one. Okay. If a page fault happens somewhere here, okay, page fault happens somewhere here, I don't need to load the page from the disk because it is already a shared file and somebody else loaded it. Sometimes I don't need to go to all 10 steps of that procedure because sometimes the pages are available in my memory. So sometimes I don't follow all of these 10 steps. Sometimes the procedure might have taken less number of steps. But this is the most general way of doing the page faults, handling the page faults. Okay. Any questions? Any questions? So what is the most expensive part of all of these 8 steps? What is the most expensive part in terms of CPU time and in terms of resource usage? Out of these 10. Number 1, trap to the kernel, not much. Number 2, again, saving some registers. Number 3, page fault has occurred and which virtual page needed? It is not much. Okay. Once you know which address caused this fault, then you need to know is a valid address or not. This doesn't take much time either. If the frame is dirty, then that frame needs to be written to the disk. That takes some time. Right? This is expensive. This causes the context switch first. Okay, context switch is expensive, and it causes the process to be blocked. Okay, and when you find a clean frame, then you need to load the frame from disk. Again, it takes some time too. So 5 and 6, they are expensive. Both of them cause the process to be blocked. Both of them cause context switches. They are expensive. And sometimes I can sometimes avoid number 5, but number 6 has to be done all the time, right? Is that correct? I need to do number 6 all the time. I cannot escape. Sometimes I can escape from number 5, but I cannot escape from number 6. Is this correct? Number 6? No, it is not correct. I can avoid that too when, I just said like 5 minutes ago, 3 minutes ago, when the pages are shared, right? When the pages are shared, I don't need to load the pages from the disk, okay? Since if they are shared and if the other process already loaded it, then I just update my pointer in my page table, then I will continue my job. So sometimes my process, even though I did some page fault, if it's a soft page fault, okay, it's not hard. If it's a soft page fault, then I can continue doing my job without getting blocked. Okay, any questions with the page fault handling? The book has a very good discussion on it, so you should read about page fault handling. Okay, remember this number 8. Faulting instruction backed up. Backing up faulting instruction is something complicated. It doesn't take much time, but it is complicated. Let's look at it. Okay. Let's say I have this instruction. What does this do? Move L. It's a 6-byte instruction. So it's a long instruction. First 2 bytes are for the opcode, okay? And there is this first parameter and the second parameter. What does this do? Just take a guess. It's a 1630 or something. I forgot the processor name. Motorola processor. What does this do? Move. It does some kind of a moving. Index moving. It says that take the A1 register, add 6 to it. Okay, that's the memory location. Take A0 register, add 2 to it. That's the second memory location. Move the contents of this memory location to this memory location. Okay. So this instruction can cause segmentation, can cause page fault in 2 places. Either this memory reference is in a page fault, or this one is in a page fault. Okay. When this instruction runs, and when you get the page fault, you don't know which one caused the page fault. When you are you look at the PC, the program counter. When the page fault happens, the program counter could be at this position, or it could be at this position, or it could be at that position. By looking at the program counter, you need to know which part of this instruction caused the page fault, so that you would know the page number that causes the page fault. So knowing which page causes this page fault is important, and it's something complicated. Okay, depending on which of these three memory references cause the page fault, the program counter might be this 1000 or 1002 or 1004 at the time of the fault. So when I figured out the causing PC number, this one, and when I handle the page fault, when I come back to this instruction, I need to back up. Okay, I need to move the program counter back to the original position. That is the beginning of this instruction. And this is called instruction backup, because instructions are causing memory page faults in the middle of the execution of the instruction, not at the end or not at the beginning. So I need to back up to the beginning of the instruction. If the instruction did something, I need to back up those things, and that becomes a complicated thing. This number 8, faulting instruction backup to the state it had when it began, and program counter is reset. Sometimes this process, backing up the instruction, is very complicated depending on the processor types. Okay, you understand what this backup means? So most of the time you are in the middle of your instruction, and you need to update your program counter to go back to the beginning of the instruction again, so that it can continue now that you know the page is available. Okay, do I have enough time to go over? That's like 151. Maybe I should stop here. Okay, the midterm exam will be on Monday at 9 a.m. This classroom and the Z23, I guess, 2 classrooms we will be using. We will start exactly at 9 a.m. If you are late, you will lose time. I will not give you an extra time, because there are other classes happening after our exam. And the exam covers everything from page number 0 of the book to the page number whatever it is that says locking pages in memory. Okay, you are responsible from everything, from each line, from each letter, from each exclamation mark. Okay, including the exercises and everything. Okay. So that's it for today. Any questions? Okay, then see you on Monday.